In this chapter, we will talk about function, especially related to the domain and the range of the functions. To start this topic, I will start from the difference between relation and function. We know that relation is the rule that connecting two variables. We have two variables in here. We have variable x and we have variable y. And we need a rule to connect variable x to variable y. That's we call a relation. For example, I can relate x, y by the relation double. So that means if I have 2 in x, as the result, I will have 4 because y is double of x. This rule is called a relation. Now, what is the difference between the relation and the function? A function from a set of element x to element y is a rule that assigns to each element in x exactly one element in y. So from the definition, function needs one value of x should be have one value of y. So it should be one pair between x and y. So one x only has one pair in y. So if we see from the diagram, this diagram is a function because each member of x has one pair of y. See, 1 is connecting to 5, 2 is connecting to 3, 3 is connecting to 3, 4 is connecting to 2. But on the second diagram, we see that 1 in element x has 2 pairs in y. So this is not a function. This is only a relation. So the difference between function and relation is in function, we have all member of x. Each member, all of them, should be has one pair of y value. Now, x is the number that we put into the rule. So the rule doubled here, I can write as y equals to 2x. Or I can write as the function f is mapping x into 2x. So from here we can see that x is the variable that we input to the rule, to the function. So we call it as a domain. And 2x will be the result of the function as we call it as range. So x in here called as domain and y here called as range. The domain and the range can be determined by the function itself. Sometimes we have to set the domain by ourselves, but sometimes the domain is given from the question. The one that we have to remember is the domain is the set value x that be inputted into the function, and the range will be the result of the function, or we call it as y-axis. So if we have the Cartesian diagram in the function fx, so all values in x-axis will be the domain, and all values in y-axis will be the range. For example, if we have y equals to square root of x, in here we have to determine the domain of the function, the values of x that can be inputted into the function. We know that the square root cannot accept negative values. So that means we have to restrict the domain. The x values only can be the real positive number. So we set the domain only works for x greater than or equals to 0. But if you have the other function, for example, y equals to x plus 3, in this function, we can see that all values of x can be fit in the function. So in here, the domain will be x element real number. So that means all values of x from negative, 0, and positive can be inputted into the function. So this is the domain. The x values are the domain of the function. And for the result, we call it as range. The y values, the fx. So if we put the domain into the function, we will have the range. And the range for y equals to square root of x will be all values that greater than 0, inclusive. We can see from here y equals to square root of x, the domain should be x greater than or equals to 0. So we can put any number from 0 and beyond. It's 0, 1, 4, 9, 12, for instance. And the range, when you put the values all to the function, you will have this result. So we call it as range. So 0 will become 0 as the range. 1, it will become 1. 4, put into the function, become 2. 9, put into the function, it's become 3. And 12, it's become square root of 12. So we can see that from here, from the domain x greater than or equals to 0, the range are from y greater than or equals to 0. And if you see from the graph, we plot the points, and we have that all the results of the function are positive and 0. So it starts from 0 up to the infinity. So that's why the range of this function is y greater than or equals to 0. So from here we can see that the domain are taken from the x-axis. From here we can see that the domain start from 1 exclusive, because this is blank dot, empty dot, goes to the left. So the domain will be x smaller than 1, exclusive. And for the range, we see from the y-axis. So the graph starts from 3, exclusive, and then increase to 4, and then downwards into negative infinity. But the range should be taken from the maximum and the minimum values of y. So in here, we can see that from a given domain, the domain are from 1. Go to the left. The minimum y, the minimum range is negative infinite, and the maximum range is 4. And the 4 is inclusive here because it's fully dot. This is fully dot, so that means the range will be from negative infinite until 4 inclusive. So I can write the y will be smaller than or equals to 4. So from here, we have to check whether we have the highest and the lowest point of the range in the given domain, because range usually needs the minimum value and the maximum value of y in the given domain. Now, to check the domain and the range, we have to know the type of relations. We have 4 types of relations. First, we have one, 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 one relation. One relation means one domain, one x will have one y, one range. The example of this is this function. So if I have a linear function, you can see that one x will have one y, one x, another one y, another x, and another y. So it's only one pair for each x. So that's one relation. The second one, we have many to one relation. Many to one relation means we have at least 2x values to be matched into one range, one y. So for example, we have the quadratic graph because we have one x, one y, but at the same time, we have another x that has the same y value. So in here, we can see that there are 2x that produce the same y value. So this is called as many one. The third one will be one to many. So in here, we have one domain, one x, matched with more than one range or what or y. So in here, I can give the example for the equation y equals to y squared equals to x. So there is one value of x that have two values of y. And the fourth one is many to many relation. So that means this is more than one x, one domain, yeah, more than one domain, matched with more than one range. The example is the circle. X squared plus y squared equals to 4. So there are two x that produce one y, or even more. So that means many x values produce many rings in y values. And from these four types, we can see that only the first two relations are the function. Because if we back to the definition, the function only can have one x, only can have one y, one pair of y. So only one and many one relations are functions, while one to many and many to many, it's not function, yeah. They are only relation, not a function, yeah. Now, to find the domain and the range, especially the range, we have to consider these two types, one and many one. One, if we have one function, for example, like this, y equals to square root of x, and for example, the domain are x from 4 until 9. So we can see that for x equals to 4, the value are 2. It's 2, yeah? And when x equals to 9, here, the value of y is 3. So the range will be, for the given domain, the range will be from 2, the y value, up to 3, inclusive. And because this is one function, yeah, you can see that the range are taken from the domain at the border. So if we draw the border, for one function, the range can be taken from the border. So we just need to find the values of y in a given border M of the domain. At the ends of the domain, we just find the value of y. But it will be different if we have many to one function, like we have in here. For example, this, I will erase this first. For example, this is x squared minus x squared plus 4. Y equals to minus x squared plus 4. We see that this function is a many to one function. So if I have a domain for x smaller than 1, so the border will be here. And since this function, this is a many to one function, we see that the minimum and the maximum are not at the end, are not at the border. You see here, the maximum value is here, within the range, within the domain. So that means if we have many to one function, we have to check whether there is a value that higher or lower within the given domain. you cannot do find the values at the border like one function. So you have to check first the type of the function. If it is one function, you can find the range by finding the values at the border at the end of the domain. But if the function is many to one function, so you cannot just find the range from the border of the domain at the endpoints. You cannot. You have to make sure that there will be no other point, no other range, no other y values that higher or lower than the border, than the endpoints in the domain. Yeah. Another example, for example, I change the domain. Yeah. Now the domain is x from -2 inclusive until 1 inclusive. So we can see that the domain are restricted only from -2 here until 1 inclusive until here. So this will be the graph. And in this domain, we can see that the minimum value of y is 0. And the maximum value here is 4, which is the 4 is not from the endpoint. So the y is from 0 until 4, not 3. Even though the endpoint is 3, yeah, the end of the domain has the value of 3 in y-axis, but since the range will be use the minimum and maximum values, so we have to consider the other value that greater than the border of the domain. So we take 4 instead of taking 3. So that's about how do you find the domain and the range from a given function in a given domain. Now let's see about the domain and range of quadratic function. In quadratic function, it will be good for us if we can sketch the graph to check the position of the y values in the given domain. Now, to sketch the quadratic function, we can ask the help of the completing the square form. We learned this before in the first chapter. So let's see the example number 1. The example number 1 is already in the completed form, completed square form, x minus 1 squared plus 2. So from here, we know that the vertex are 1, 2. And the type of the quadratic graph is in the U shape, since the x squared is positive. The coefficient x of the x squared is positive. If you forget about this, please check again the video about quadratic equations and functions. You may refresh your understanding in the quadratic graph and the completing the square form in that video. Now, that means we can find the vertex 1, 2. So this is 1, 1, 2. So here, 1 and 2. And this is the U shape. The vertex is the minimum point. This is minimum. So we can draw Yeah, sketch like this. So from this sketch, for number I, when x are real number, so x can be all number from negative infinite until positive infinite, we can see that the range, the y values are from 2 and up. So we can see that y is greater than or equals to 2 for the range. Because you will never find the values less than 2. That's why it will be better if you can step it. And we need to use the completing the square form to sketch it easily, because we can find the vertex and we can find the shape. Is it a U shape or N shape? To determine the direction of the rays. Is it greater than any point or smaller than any point? Yeah, this is quadratic, so this is many to one function. So we have to consider whether we have the lowest point instead of the given point from the domain. So that's for the I. And for the I use blue now for I. X greater than 0. So we need to find the value of f0. So f0, if you put into the function, so you put 0 here. 0 minus 1 is 1, plus 2 is 3. So 0 is here, exclusive. Yeah, so it's an empty dot. This is 3. X greater than 0 means the domain from 0 to the right. The range will be from 3 going down and then up. Yeah. So in here, we can see that the range will be from 3 going down, from 3 going down, and then up again. So the minimum in here, the minimum is 2. The minimum is 2. And the maximum is infinite. So that means the range will be y greater than or equals to 2. So we use inclusive here because 2 here is inclusive within the domain. The 0 is exclusive, but since the minimum point is when x equals to 1, which is within this domain, so it's inclusive. That's why the domain includes, the range is inclusive. Let's see the third one. I use green. X smaller than negative 4. So again, we have to find the negative 4. So negative 4 minus 1 is negative 5. 25 plus 2 is 27. So negative 4 will be here. And the value exclusive will be here, 27. And x is smaller than negative 4. So it's from negative 4 to the left. So in the graph, it will continue up. So that means this is 1, 1 function. For x smaller than negative 4, it's a 1, 1 function. So we can just take the value of the border in the domain. So we can just use this value, 27. And you see from the graph that the graph will be up. So the 27 will be the minimum, the lowest point in the range. So I can say that the range will be y greater than 27, exclusive. Because the range, the domain here is exclusive. For the last one, -2 and 1. So I find -2 and I find 1. So -2 is -3 square. 9 plus 1 is 10. And then 1 is 0 plus 2. It's 2. Yeah. Now, from -2 until 2. Sorry, -2 until 1. So it's from -2 here. Here, it's 10 until 1. So the domain will be only in this interval. So the range will be from here to here. Both are inclusive. And this is the graph. Now this is 1, 1 function. So the range will be taken from the border, from the limit of the domain. So we can just see the minimum is 2 and the maximum is 10. So y is between 2 and 10 inclusive. That's for number 1.